The objective of this lesson is to write and solve equations of functions. Example 1. At a rental company, small trucks rent for $19.99 and a charge of 25 cents per mile is added. Write a function to find C, the cost of renting a small truck for M miles. Let's start by writing the equation. We're trying to write a function to represent C, the cost. So let's start with C equals. The cost of renting the small trucks is $19.99 no matter what, and a cost of 25 cents per mile is added. So we're going to add on 0.25 times M for 25 cents per mile. To write this in function notation, we'll simply replace the C with C of M, which means the cost of M miles is $19.99 plus 0.25 M. Let's fill in the dependency statement. We're trying to decide what depends on what. So let's look at our equation. We have an M inside the equation where M represents the miles. So M is inside, which represents our input, our independent variable. C, cost, is outside the equation, so it represents our output, which is also the dependent variable. To fill in our dependency statement, we remember that it's the dependent variable that depends on the independent variable. And I know that from my equation, M is the independent variable where M represents the miles, and C is the dependent variable where C represents the cost. And that just makes sense. The cost of renting the truck depends on how many miles you drive it. So our independent variable, once again, is the miles, M, and the dependent variable is C, the cost. Let's answer some questions about this function. What would it cost to rent the truck to drive 32 miles? Since they're asking for the cost, we're going to solve the equation for C. They're giving us 32 miles, so this represents M. M equals 32. So in our equation, we're going to find C by calculating 19.99 plus 0.25 times 32, the number of miles. Typing this in our calculator, 1999 plus 0.25 times 32, we get 27.99. So what would it cost to rent the truck to drive 32 miles? $27.99. If the cost for renting the truck M miles is $300.50, how many miles was the truck driven? This time, they're asking us for how many miles the truck was driven, so we need to solve our equation for M. They're giving us C, the cost of renting this truck. So in our equation, we're going to replace C with 300.50, and then we'll solve for M. So let's draw our line, box the variable, and do the opposite of what's not in the box, the 1999. Let's subtract it on both sides. In our calculator, if we type 300.5 minus 1999, we get 280.51. The last step is to divide both sides by 0.25. And in our calculator, this gives us 1122.04. So how many miles was the truck driven? 1,122.04 miles. Let's try another example. The shipping and handling charges for a mail order company are $2.75 fixed charge and 50 cents per pound. Write a function to find C, the cost of mailing an order weighing P pounds. Since they want a function to find C, let's start with C equals. It costs $2.75 no matter what, and 50 cents per pound. So we'll add on 0.50 times P. In function notation, we're simply going to replace the C with C of P, and the rest of the equation stays the same. Looking at our equation, we can identify the independent variable and the dependent variable. The independent variable is inside the equation. The dependent variable is outside. So our independent variable here is P, which represents the pounds. The dependent variable is C, which represents the cost. This time, we're going to fill in a dependency statement, but this time, instead of depends on, it says is a function of. Is a function of is just a fancy way of saying depends on. And we know that the dependent variable depends on the independent variable. Likewise, the dependent variable is a function of the independent variable. So we can easily fill in that C, the cost, is a function of or depends on P, the pounds. And that just makes sense because obviously how much it's going to cost depends on how much the package weighs. Next question asks, what is the value of C of 20? Well, first let's think about what this means in words. C represents the cost and the input is 20. So this actually means what is the cost of mailing a 20-pound package? To find it, we're simply going to take our function and replace P with 20. So let's compute 2.75 plus 0.5 times 20, and this gives us a cost of $12.75. Next question, what is the value of P if C of P equals 56? Let's think about what this means in words. This time, we don't know how many pounds were mailed, but we do know the cost of the P pounds was $56. So this question is asking how many pounds can be shipped for $56. This time, we're going to take our C in our equation and replace it with 56. And we'll have to solve for P, the pounds. So let's draw our line and box the P and subtract 275 on both sides. So this gives us 53.25 equals 0.50 P, and then we'll divide both sides by 0.50. So we find that P equals 106.5. So what is the value of P if C of P equals 56, or how many pounds can be shipped for $56? The answer, 106.5 pounds. One last question. A store manager begins each shift with the same total amount of money. She keeps $200 in a safe and distributes the rest equally to 5 cashiers in the store. This situation can be represented by the function y equals x minus 200 divided by 5. So part A, what does the variable x represent in this situation? Well, let's think about this equation. We know that the manager begins the shift with the same total amount of money. She puts $200 in a safe. So this minus 200 represents how much goes in the safe. And then she distributes the rest equally to 5 cashiers. So that's the reason for the division by 5. So what does x and what does y represent in this problem? Well, x has to be the amount that she begins with, because she begins with that amount and then subtracts 200 and distributes it among the 5 cashiers. So the y must be how much money each cashier gets. So what does X represent? Well, A says the total amount of money the manager has at the beginning of the shift. That is actually correct. She begins with X, gives away 200, and then divides by 5. Answers C and D are referring to the variable Y. How much money each cashier has at the beginning of the shift would be what Y represents. Okay, so A was the correct answer. Part B, at the beginning of each shift, each cashier receives between $100 and $200. What is the domain of the function for this situation? So we have two equations to solve. We know that each cashier receives between 100 and 200. So Y equals either 100 or 200 or somewhere in between. So let's take our equation and replace Y with 100 and with 200, and let's see what the domain would be for this situation. In other words, how much money does the manager have at the beginning of the shift if she gives each cashier between 100 and 200? So let's solve. For each one, we're going to begin by multiplying both sides by 5. So for the first equation, I get 500 equals X minus 200. And for the second equation, I get 1,000 equals X minus 200. In both equations, I'm going to finish by adding 200 to both sides. So, if the cashier receives $100, then the manager began the shift with $700. If the cashier each receives if the cashier each receives $200, then the manager began the shift with $1,200. So the domain for this function is any amount between 700 and 1,200 written as a compound inequality. Now go practice the skills you just learned by completing your assignment.